Mathematics at Init College, a YouTube channel for high school mathematics education. Mathematics 4, Swedish high school education system. Differential equations. Hi, this is Babak. In this video I am going to solve the following problem for you. Let me read the problem for you first. Show that y equals to sine of pi times the square root of x plus 1 is a solution to the following differential equation. 4 times x plus 1 times y double prime plus 2 times y prime equals to minus pi squared y. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. Okay, now let me solve this problem for you. So you know that a differential equation is given to us and a solution is proposed to us. So the problem claims that this is indeed a solution of this differential equation and we need to investigate the truth of this claim. So it means that I need to calculate the left-hand side and show that for this particular function, if I calculate the left-hand side, it becomes identical to what is written on the right-hand side. And if you see, this is a second order differential equation because the highest derivative appears as the second order derivative. And I have to calculate y prime and y double prime in order to be able to calculate the left-hand side and then compare it to the right-hand side. Okay? So I start with calculating y prime. So the given function is this one, sine of pi times square root of x plus 1. Now I differentiate this function. So I need to recall this formula. So if you remember, if you have sine of a function u and if you want to differentiate it, the rule is to write cosine of u, of course, but you need to remember to multiply by the derivative of u according to the chain rule. And now this expression as a whole is playing the role of u in my case. So this becomes cosine of u but then multiplied by the derivative of u. Yes? Okay. But now here I have a constant pi, so I can take it out from the derivative and put it there, but this is a square root of a function, but you know that the square root of a function, if I want to differentiate it, it becomes 1 over 2 square root of the same function, but multiplied by u prime because of the chain rule. Now I will give the role of u to this function, and you know that if this is going to be u prime is simply 1, so here I don't need to be bothered about this u prime, that's actually 1 here. So what I do, I will take this pi out and put it here in the first to be a little bit more organized, and then I will write this here. And then the derivative of that function, as I told you, is just simply 1 over 2 square root of x plus 1. And let me write this compactly a little bit. So finally, what I get is this. Y prime is equal to, I have a pi here, I have a 2 here, so let me write pi over 2, and then multiply it by a fraction whose numerator is cosine pi square root of x plus 1. And its denominator is square root of x plus 1. Yes? So this is the first order derivative of this function here. So let me... Okay. So this is the first order derivative, and now I need to differentiate it once more. But if I want to differentiate it once more, I have to use another derivative rule, which is the quotient rule. Why? Because I have a fraction here, and you remember that if I have a fraction f over g and I want to differentiate it, it becomes another fraction whose numerator is the derivative of the numerator multiplied by the denominator minus the numerator multiplied by the derivative of the denominator and divided by the denominator squared. So here, this function in the numerator will play the role of my f, and this function here will play the role of g. Yes, so I will use this formula with this function as f and this function as g to be able to find the second derivative of y. But of course you know that pi over 2 is a constant, so I don't need to be bothered by this pi over 2. I simply put it here, pi over 2, and then I will try to calculate this. Okay, so what I need to do is the derivative of the numerator. Let me write everything explicitly, not to be in a hurry, okay? So this becomes the derivative of the numerator. I am just following exactly the quotient rule. So the derivative of the numerator multiplied by the denominator itself minus the numerator multiplied by the derivative of the denominator. And then, if you remember, divided by the denominator squared. Yeah, let me be patient and write everything. Okay, now I need to continue this calculation. So here I have the derivative of cosine, and this is very similar to the derivative of sine. So, but what you need to remember is that the derivative of cosine of u is not sine of u, is minus sine of u, but multiplied by u prime. So here this function is playing the role of u, and then I have cosine u prime, so I have to follow this rule. Yes? So then I will continue. So I have a pi over 2 in the beginning, and then, by the way, let me write this, so it becomes negative sine of the function u, which is this function, but multiplied by the derivative of u, which is this function. And then if you remember, so far what I have written so far is just the derivative of this function, and then you see after that I have a square root of x plus 1, so I will write a square root of x plus 1 as well at the end. And then I will have minus, I will copy and paste this part, so it is cosine pi square root of x plus 1. And as I mentioned earlier, the derivative of this function here is exactly this, because of the same reason. So it becomes 1 over 2 square root of x plus 1. And then denominator to power 2, so this exponent will cancel this square root sign. I will have x plus 1. Okay. Okay, but there is also another derivative left, so let me complete this. Okay, so what I need to do, let me write it here. So you see here, let me change my color so you don't get confused. So this part is again 1 over 2 square root of x plus 1. And then of course I have a pi here, so let me write pi there. But then you see that if I multiply this by this factor, so this factor will be here, then what happens? This one and that one are totally cancelled, and I am left with pi over 2. So the whole thing here is nothing except pi over 2, and I will write it here, so it becomes negative pi over 2. Of course I have another pi over 2 here, so let me continue. So I have that pi over 2, then I will have minus pi over 2 as I mentioned earlier, then I have sine of pi square root of x plus 1, then I go to this one. This one is exactly the same, so I can just write it as minus cosine. If I want to write it more compactly, I write it as one single fraction whose numerator is this and whose denominator is 2 square root of x plus 1, and the whole expression is actually divided by x plus 1. Okay, but I want to simplify a little bit. I want to rescale this fraction by this factor, because I have a partial fraction here. I want to get rid of that partial fraction. So I multiplied the numerator and the denominator by this factor. Okay? And then finally, let me write y double prime here. So this becomes equal to, this implies that y double prime is equal to, I have a pi over 2 here. Yes. So, and then I will have this fraction. If I multiply the denominator by that factor, so it becomes 2x plus 1 square root of x plus 1. So what I am doing, I am multiplying both the numerator and the denominator by this factor. So this expression will be multiplied by that factor, so that's the denominator. When I multiply this part by that, this is totally gone. What is left for me is this, and I have a negative sign. So let me write it at the very end, so it becomes minus cosine of pi square root of x plus 1. Yeah, it is not very good here. Let me clean this one. So it becomes minus cosine pi square root of x plus 1. And then this expression should be multiplied by that. So, and then this 2 and that 2 are cancelled when I multiply. So I am left with minus pi square root of x plus 1. And then I have sine of pi square root of x plus 1. Yes? Okay. But now I can split it actually. I can split this into two parts. So this becomes equal to, I divide this expression by the denominator minus this expression by the denominator. Okay? So then what happens? So this means that y double prime is equal to pi over 2, and then I have this situation. That's minus pi square root of x plus 1 sine pi square root of x plus 1 divided by 2x plus 1 square root of x plus 1 minus cosine pi square root of x plus 1 divided by 2x plus 1 square root of x plus 1. Okay? So now let us see what happens. I have a factor of 2 here and a factor of 2 here in the denominator. So I pull it out. So it would be 1 over 2. This will be gone. This will be gone. So this becomes pi over 4. Yes? But I have a negative sign here and a negative sign here. I will take that negative sign out. So this becomes positive. So this becomes positive. And then here, this expression and that expression are gone. Okay? So I will do these changes and write it once more. So y double prime is equal to minus pi over 4. And then let me cancel this one here with that one are cancelled. And by the way, you see that you have this one is in common between these two. So let me pull that one out as well. So this will go to the denominator. So this becomes x plus 1. And then what is left for me? I am left with 1 pi sine pi square root of x plus 1. Yes? And then I will have plus cosine pi square root of x plus 1 divided by square root of x plus 1. So finally, this is my y double prime. Yes, so that is my y double prime. And let me make it a little bit nicer. Now everything is ready. So here I start from the left hand side. Let me make it a smaller so that you can see them simultaneously. So left hand side, the left hand side is now equal to, I am supposed to multiply y double prime by 4 times x plus 1. But if I multiply y double prime by 4 times x plus 1, this becomes the expression that I want, but I have also I have to multiply this one by exactly that combination, so this will cancel that one, yes? So from here, 4 times x plus 1 times double prime, so let me repeat. If I multiply both sides of this relation by this factor, the left hand side becomes exactly what I want. The right hand side, when I multiply this will cancel that one. I am left with negative pi, and then I multiply negative pi inside, okay? So then it becomes so let me write it in this way. Yeah, I think it would be more effective if I do the calculations once more. So this means that 4 times x plus 1 times y double prime is minus pi squared sine of pi square root of x plus 1. I think if I do it in this way, it is more it's easier, okay? And then what happens, I have another minus pi, so it will be multiplied here. Okay, so what I did here, I calculated y double prime, and then I multiplied both sides by this expression. The left hand side becomes exactly this. The right hand side will be, this one will be cancelled. Minus pi will be left, and minus pi I will multiply here. It becomes minus pi squared, and I will also multiply it there. Okay. But now something interesting here happens. Actually, if I ask you what is this part, you can immediately answer, look here, this is actually y. So instead of this one, I can simply put y. And if I ask you what is this one, you can also immediately answer that, yes? Because look here, this is exactly this combination. You see cosine pi square root of x plus 1 in the numerator, square root of x plus 1 in the denominator. I also have a pi in the numerator. The only thing that I do not have here is just a factor of 2 here. So I can divide this by 2 and multiply it by 2. Then this expression is just y prime, and this expression is just y. So let me just write them. But you remember, I divide by 2, multiply by 2, this is y prime. So this becomes minus 2y prime. So this means that 4 times x plus 1 y double prime is equal to minus pi squared y minus 2 y prime. But that's interesting now, because if now I move this one from the right hand side to the left hand side, what I get is 4 times x plus 1 y double prime plus 2y prime equals to minus pi squared y. And that is exactly this differential equation. So it means that if I start the calculating the left hand side using this function, I immediately get to the right hand side. Okay, so I hope that this video has been useful for you. Until the next video, be safe and goodbye.